My name is Vaimuna. I am studying first year MPCS. Today I am going to tell about the longitudinal waves and transverse waves. These are also called progress waves. First, what is a wave? A wave can be described as a disturbance that travels through a medium from one location to another location. Consider a slinky wave as an example of a wave. This is a slinky wave. Next, these are the formation of vibrations. Let me see in the diagram. First, what is a longitudinal waves? A longitudinal waves in which particles of medium move in a direction parallel or antiparallel to the direction of energy transport. Let's say these the waves moves in parallel direction and antiparallel direction. This is the direction of waves which is going on to antiparallel and parallel waves. These are the longitudinal waves formed in a slinky wave, compression and refraction and wavelength. Next, what is a transverse wave? In physics, a transverse wave is a wave whose oscillations are perpendicular to the direction of the waves in advance. This is in contrast to a longitudinal wave which travels in the direction of these oscillations. These are the example of water waves are an example of transverse waves. Here let me see the transverse wave is formed in a water. Transverse wave diagram. Here is the example. To form source from the I direction through wavelength, the transverse waves is formed. In this example, let's laws of transverse wave in a stretch string. We know that the general equation of modulus of vibration in a stretch string having transverse waves is Vn is equal to n by 2L velocity. We know the velocity of transverse wave is V is equal to root over T by m square m. Then velocity of n is equal to n by 2L root over T by m. Here n is equal to 1, 2, 3 and so on. N is not equals to 0 where L is the length of the string, T is tension of the string, m is the linear mass density. N is number of modes formed in the string. Now we have to explain laws of transverse waves as follows. First law. When tension T on the string and linear mass density m are constant, then the frequency of fundamental string mu is inversely proportional to the length of the string L. That is, Vn is directly proportional to 1 by L. Here T and M are constant. Next, second law. When length L of the string and the linear mass density M are constant, then the frequency of fundamental mode is directly proportional to the square root of string tension T applied on a string, that is Vn is directly proportional to root T. Here L, M and are constant. Next, third law. When length of the string L and linear mass tension applied on string T are constant, then the frequency of fundamental mode Vn is inversely proportional to the square root of linear mass density in the string. That is, Vn is directly proportional to 1 by root m. Here L and T are constant. These three laws are called as laws of transverse wave in a stretched string. These laws are verified by sonometer experiment practically. Let's see the difference between longitudinal waves and transverse waves. Let me see transverse waves and longitudinal waves differences. We can see the diagram of transverse wave in the figure. This is the longitudinal waves in longitudinal waves. Second one, particles vibrate in a direction of perpendicular to the direction of propagation of the wave in transverse waves. Second, in longitudinal waves, particles can vibrate in a direction parallel to the direction of propagation of the wave in longitudinal waves. Next, third one, crests and troughs are formed in a transverse waves. Third one, in longitudinal waves, compression and refractions are formed in longitudinal waves. Fourth, in transverse waves, formed on the surface of solids and liquids in transverse wave, formed in solids, liquids, and also gases in longitudinal waves. Transverse wave may be elastic waves or non-elastic waves. In transverse waves are formed. Example, light wave and radio wave. Next, longitudinal waves only elastic waves and also called mechanical waves. Example, sound wave, seismic wave, etc. This is formed in longitudinal waves. In transverse waves, do not create pressure difference in the medium of transverse wave. In longitudinal waves, it creates pressure difference in the medium of longitudinal waves. You can see these are the difference between transverse waves and longitudinal waves differences. Thank you.